Hi Math 1, let's take a look at lesson 3.5, which is going to review a lot of the things from the past, so hopefully this makes sense. The first thing we're going to do is talk about graphing linear functions. So when you have a line, okay, with a slope that's either increasing or decreasing, there's a couple of key features we were supposed to mention. Okay, so the key features for this equation, okay, you could put a point, or some people liked seeing this kind of like in table form. It doesn't matter how you do it. There is no x value. This is the short form. So we're going to have 0, and then the y value is 5. Okay. The slope for this line is -2, and I'm going to put that over 1, which means my line is going to be decreasing. Okay. Let's get the starting point on. 0, 5. That is called the y-intercept. And then we're going to go down 2 over 1. Down 2 over 1. Down 2 over 1. You're going to keep going till you run out of graph paper. Okay, we're going to go ahead and graph a nice, straight, long line here. And we're going to put arrows. This does look good because it is decreasing. Okay, number two. This is more point slope form. Okay, so if you take a look at your point, it could be in a table form or it could just be like in a point form. The x value, we're going to switch to a positive, and the y value is a 4. The slope for this one, okay, out in front of x, don't forget to look at the sign. This is a positive 1/2. Okay, so we have the point 3, 4, 3 to the right, 4 units up, there's the point. We're going to go rise up 1, and you always go over to the right 2. Up 1, over 2. Now we need to go the other way, so we'll have to reverse it, to do the opposite. We'll go down 1, left 2, down 1, left 2, down 1, left 2. Keep going till you run out of graph paper. Draw a nice long line with arrows. Does this line look good for a slope that's positive? Okay, so if you have positive slope, okay, it should be an increasing line, okay, which this is, an increasing line, yes? Okay, let's go down here and review graphing exponentials. Okay, graphing exponentials was a little different, okay, because we don't have a slope. Remember, if it's an exponential function, we're going to have a curve. We're going to have a curve. And the way that we do this, okay, is by making a table. Okay, so we're going to make a table right here. We're going to have x values and some f of x values. So we'll start with 0. Okay, the starting value right there is 5. Starting value is 5. I know it's a 0 because there's nothing by the x. Okay, and you make a table of values, 1, 2, 3, 4, and we're going to go ahead and multiply by 3. Okay, so the pattern is multiply by 3. So 15 times 3 is 45, times 3 is 135. I think I'm going to stop there. Okay, that's 4 good points. So I'm just going to get rid of this one. Let's see, in terms of scaling, got to get to 135. I'm going to go by 15. 15 plus 15 makes 30. 45 plus 15 makes 60. 75, 90, 105, 120, 135, perfect. On the x-axis, it's just 1, 2, 3. And let's go ahead and get our graph drawn. Okay, so we'll start at 0, 5. 0, 5, right there, a third of the way. 1, 15, 245, okay. Going by 15s was a good idea because a lot of these are multiples of 15. 3 comma 135. There we go. Okay. Remember, when you draw your exponentials, okay, you're going to be asymptotic here to the x-axis, like landing the plane, and then over here, curvy, curvy up like this. Okay. Since you're multiplying, okay, this is going to be increasing. The curve is increasing up. Makes sense. All right, let's go take a look at this last one right here. I noticed that this is an exponent. This is an exponential function. Okay, we don't have slope. We're going to make a table of values. So let's go make a table for this one. Let's make a table x and f of x. So the starting value, since x is alone, is 0. Okay, and this is the starting value. We're going to start with 80. And then the pattern here, the pattern is multiply by 1/2. Multiply by 1/2. So if I multiply by 1/2, that's 40. 2 would be 20. 3 would be 10. 4 would be 5. All right, so how high does this graph need to reach? The highest value that we have here, the highest value is 80. And I need to get that on my paper. I see a lot of these are by tens. I think going by tens would be a good idea. All right, if I do 10, 20, 30, 40, 50, 60, 70, 80, I'll reach the highest number I need to, and a lot of these points will be easy to graph. Okay, sometimes what you could do, let's see, 8, 9, 10, there's 12 boxes, so you could take the biggest number, 80, okay, and you can divide by 12 boxes, and that makes 6.66, which is icky. You have to go up, so we could have gone by 7s. That would not have been easy to graph. So jumping all the way to 10, you have to go higher, would make this a lot easier. Okay, the x-axis is always nice and easy. We're going to label these 1, 2, 3, 4. And let's get our points on. 0 gives us 80. 1 gives us 40. 2 gives us 20. 3 gives us 10. 4 gives us 5. Remember, this graph is not going to suddenly go down below the x-axis. Half of 5 is 2.5. 1 point, it's just going to get smaller, smaller. Okay, so make sure when you do this, curvy, curvy down. You land the plane, approach the x-axis, closer, closer, but never touch. Make sure you get nice and flat there on the end. Okay. That was a review of the graphs that we know how to do. Let's go ahead and review, okay, how to write an equation of a linear function. Okay, so a linear function, this means that you're going to have a line. You're going to have a line, and there's a couple things that we do. Okay, so we start with the starting output, and then it's plus or minus the pattern. A two-sided pattern, or sometimes we even started calling this the slope, right? The slope. And then we finished it off with x minus the starting input. Okay, so just to refresh how we did this, a lot of people took the information, kind of put it into a table. You can certainly do that if you need to. Okay, so when it says that the equation passes through the point 1, negative 7, okay, you could put that into your table, x and f of x. Some people can do it straight from that point. And now when it says the slope is 4/5. That's the pattern. We have all the information we need. Okay, we have the starting output, we have the slope, the input. Let's go ahead and write this equation. Okay, so we're going to have f of x equals f of x. The starting output is right there, negative 7. And then the slope was just given to us. Okay, the slope is plus a positive 4/5. And then we have to do our x value, x minus the starting input. The starting input was 1, so it's x minus 1. Okay, this is called point-slope form. Point-slope form because we had a random point and a slope. All right, let's see. Write the equation of a line that passes through 2 points. So what a lot of people did back when we learned this is they put this information into a table, x and f of x. So 2 goes with the 5 and 4 goes with 9. Okay. The reason they did this is because they liked the table to calculate the slope. Okay. So I look over here on the y side, that's up 4. Okay, so the slope is delta y, and the delta y is a 4. Delta y. And then, remember, we had to look at the other side. Okay, how did x change? What's delta x? That's plus 2. So delta x is positive 2. Delta y over delta x, if this can be divided or reduced, you have to. 4 divided by 2 makes it 2. Now we can go ahead and make our equation because we have our slope and we have our starting point. F of x equals, okay, starting output is 5. Okay, then comes the slope. Okay, the slope is a positive 2, so plus 2. Then comes the x value, and I notice that it starts with a 2, so I'll say minus 2. Okay, this is also in point-slope form. Okay, if this was a negative number, you'd switch there to a positive. The x has the switcheroo. All right, how do you write equations of exponentials? Exponentials is very similar. Okay, so you're going to have the starting output. Okay, you have your starting value. Okay, and then we had our common ratio, or our constant ratio. Okay, and that's going to be a multiply or divide pattern. And some people said, isn't it always multiply? Yes, because you just put a fraction there. So that's your multiply pattern. And then you say to the power of x minus your starting input. Okay, so that's how we did those. Let's review a little bit. The starting number of students in the room was 32. Okay, so what we're going to do for exponentials, a lot of times with exponentials, whether you're graphing or writing equations, is make a table. Make a table for exponentials. Okay, so we have the starting number. When it says start, that means you're going to have a 0. The starting number was 32. Okay, so this is students. And then each, that's an important word, each minute. So these are minutes. 1, 2, 3 minutes. The number of students was half. So I need to do half. Half of 32 is 16. Half of 16 is 8. And then 4. As long as you have your starting, input, output, and you have your pattern, you have the constant ratio, we can make the equation. So f of x starts with 32. The pattern is 1/2, and it just goes to the power of x. Okay, this next one is nice because they gave me a table. It shows the amount of snowfall each day. Write an exponential function. Sure thing. So this is snowfall. Right here. And what's happening to the snow? What's happening? Now it said exponential, so I'm thinking about a multiply or divide pattern, and they're getting bigger, so this is multiply by 3. We have our starting input, output, and we have the constant ratio, so we can write the equation right away. Okay, the starting value is 2. The pattern is times by 3. And then it's going to be to the power of x. But since this is a 1, we're going to say minus 1. And that is a review of exponential. Okay, let's talk about something just a little bit new, okay? And that's forming equations. Forming equations. So how do you make an equation? Okay, let's take a look at these two things right here. The first thing we have, okay, is variable x. Variable x, okay? Variable x has to get multiplied by 3. The way that you say multiply is you put the number in front. 3 times x. All right, now step 3. We're going to subtract a 5. Minus 5. And then the result is 17. That means equals. Okay, result means equal sign. What about if I did it a different way? So what if we took variable x, and the first thing we did was subtract 5. Variable x, subtract 5. All right. The third step says multiply by 3. I can't just put the x in front, or the 3 in front of the x. How am I going to say multiply everything by 3? How do you say multiply everything you have here? Everything. We're going to have to use parentheses. All of that gets multiplied by 3. Okay, everything uses parentheses. Okay, now take all of that stuff and the result is 17. The result is 17, okay? So I see that if I rearrange things a little bit, does the order really matter? Okay, and the answer is yes, the order totally matters. You have to follow the steps in order. You're going to get a different equation. Different answer, okay? So let's form some equations here. Number 1, form an equation with these steps. Okay, so the first thing is variable x, yep. Multiply it by a 2. So I'm going to put a 2 out in front. 2 times x. Okay, now take all of that. Take all of that and add 7. Okay, add 7. The result is negative 8. Negative 8. All right, let's do it again. Take variable x, divide by 3. Ooh, that's fun. X, okay, divide by 3. Divide is like a fraction bar, right? Divide. We don't ever use the one with the dots in the middle of an equation, do we? Step 2, we're going to add 11. Okay, take all of that stuff and add 11. All right, the result is 23. 23. Good job forming equations. Good job. Form an equation. Okay, take variable x, multiply by negative 7. Okay, remember, multiply has to go in front. What if I said minus 7? No, wait, that doesn't look right. That looks like subtract. Okay, we have to put the negative 7 in front of x. Otherwise, it would look like subtract. The number goes in the front. Step 2, subtract 13. The result equals 50. Equals 50. Take variable x and add a 6. Add a 6. Okay. Step 2, divide by 4. Ooh, divide by 4. So all of this has to get divided by 4. Would it look good if I just did that? That just looks like the x. I have to take everything I have so far. So you have to draw a big, long divide bar. All of that gets divided by 4. And then the result is 15. Okay. How was this equation made? Okay. The first thing I want you to do is find variable x. Find variable x. Okay, what's right by variable x? That's a 4. When you have a number next to a variable, that means multiply. So the first thing they did was multiply by 4. Okay, now what's next to that? Okay, next to that I see minus 9. So that must be the second step. The second thing they did was subtract 9. Okay, and then the result is 11. How is this equation made? Okay, find variable x, and what's the closest thing to him? Divide by 6. X over 6. Okay, so the first thing they did was divide by 6. What was the second thing that they did? Okay, take that bubble and look to see what you have. The second thing was they added a 7. And then the result was a 5. Great job, Math 1.